Hello everyone, welcome to Introduction to Data Mining class. In this unit, we will introduce k-means clustering. The simplest and most fundamental version of cluster analysis is partitioning, which organizes n objects into k-exclusive groups or clusters by iterative relocating data objects. Two commonly and widely used partitioning methods are k-means and k-medoids, where k-means uses a centroid-based technique, while k-medoids uses a representative object-based technique. No matter k-means or k-medoids, the letter k indicates the number of clusters, which is a parameter required when applying the algorithms on a dataset. This animation will demonstrate how k-means partition clustering works. Assume we have 12 data objects as shown on the screen, and we know the number of clusters k is 3. Step 1, we randomly initialize 3 seeds as centroids of clusters. Each centroid is represented as the star symbol. The different color of the centroid represents different cluster. Step 2. We measure the distances between each data object and all 3 centroids, and assign each data object to the centroids with the shortest distance. We change the color of each data object to illustrate the data object assignment. Step 3. We update the centroids of clusters by calculating the mean of data objects assigned to the same group for each cluster. Step 4. We repeat steps 2 to 4 until no data object is relocated. This summarizes the steps for k-means clustering algorithm. To implement k-means clustering, we initialize k-seeds randomly representing the centroids of k-clusters. Then we measure distance between each object and the centroids of k-clusters. The next step is that we assign each object to the nearest cluster based on the distance measured. Then we update the centroids of k-clusters. We repeat steps 2 to 5 until no object is relocated. The problem of the k-means clustering algorithm is that if we use k-means clustering algorithms on identical data set, we might obtain different results. The reason is that the k-means clustering algorithms randomly generate seeds to represent the centroids of clusters and assign data object to clusters. Further, k-means algorithms require to know the number of cluster k in advance. In addition, k-means clustering algorithms are sensitive to outliers, When an outlier is assigned to a cluster, the outlier may have great impact on the centroid update. Another problem is that in k-means clustering, a cluster might become empty if no data object is assigned to the cluster.